Hi everybody, welcome back to my classroom. Today's topic is exponential rules and exponential functions, including exponential model problem. Let's start from exponential rules. I'm going to give you basic 7 rules and 3 more rules related to radicals. Okay, first rule, a to the 0 powers. Any numbers, anything 0 powers is always 1. Anything, any numbers, any expressions, 0 power is always 1. We call it 0 power rule. Second rule is a to the negative k powers. That is equal to 1 over a to the k power. We call this rule negative power. Negative power. I can give you some examples. What is 3 to the negative 2 powers is equal to 1 over 3 squared. So it is 1 over 9. So what about x to the negative third power is equal to 1 over x cubed. Number 3, third rule is a to the x powers times a to the y powers. That is equal to a to the x plus y power. We call this rule product of powers. If these two exponential expression has same basis and then they multiplied by each other, you just add two exponents. A to the x power times a to the y is not a to the xy. You have to add those two exponents, x plus y. What about number 4? Fourth rule is a to the x power divided by a to the y power. The other word, a to the x power over a to the y power. We have to subtract two exponents. That must be x minus y power. Number 5, power of power, x power to the y power, power of power, right? So we call this rule power of power. In this case, you multiply two exponents, xy powers. Number 6, AB times AB whole things x power is each one's x power, a to the x power times b to the x power. Number 7 rules, a over b whole things x power is equal to a to the x over b to the x. These 7 rules are basic exponential rules. I'm going to give you 3 more rules related to radical, square root. Number 8, square root of x. How can you change square root of x to exponential expression? Square root of x equals x to the 1/2 power, 1 over 2. What about number 9? Nth root x, cube root, fourth power, fourth root, fifth root, okay? Nth root x is x to the 1 over n power. And then nth root x to the m. It is x to the m over n powers. Example, x to the negative 3 over 4. How can you change this to positive exponent? You can use negative power, right? So 1 over x to the 3 over 4. And then you can use a radical, right? 1 over 3 over 4 is m over n. M is 3, n is 4. So 4th root x cubed. So you have to understand, change this to this. Sometimes to solve some other problems, you can change this expression to this. You can find some problem about exponential rules with the radical expression in SAT. Okay, you can use these 10 rules to solve some problem. We can go next, exponential function. Exponential function's basic form is y equals a times b to the x powers. For example, y equals 3 to the x powers. What is a, what is b? This is 1 times 3 to the x powers, right? This is a, b is 3. What about next example? Y equals 5 times 1/2 to the x powers. Okay, what is A, what is B? A is 5 and B is 1/2. In exponential function, A times B to the x powers, that A actually means y-intercept. In the modeling problem, we have a lot of different types of modeling problem, linear model, and then quadratic model, and exponential model. Some scatter plot actually presents direct variation model or inverse variation model too. Okay, I will talk about the 5 different models in the SAT later, next lecture. But today I'm focused on just exponential function and exponential modeling problem. In the exponential modeling problem, that y-intercept means A, that is initial value. Do you remember that in y equals mx plus b form, the linear model problem, in linear model problem, y-intercept was b. B was y-intercept, and then B represent initial value. But exponential model problem, A times B to the x powers problem, okay, initial value is A because y-intercept is initial. Why that A is y-intercept? If you plug in 0 for x, if that is 0, A times B to 0 powers, right? Anything 0 powers is 1, so A times 1 is A. If x is 0, y is A. So y-intercept means y value when x is 0. That's why A is y-intercept. And then modeling problem, that is initial value. What is next? There's a B here. We call this is base. Depends on the B, okay, the graph is different. If B is greater than 1, that's an increasing function graph. So B is between 0 and 1, is a decreasing function graph. Before we go there, okay, in A times B to the x powers, that B is not 1, and then the B always should be greater than 0. B is not 1. If B is 1, that is not exponential function anymore. 1 to the any power is just 1, that's why. And then B should be positive. So B is not 1, and then B is greater than 0. Okay, let me draw the graph. There are two types of exponential function graph. First one is the base is greater than 1. Yeah, in y equals a times b to the x powers. If that base b is greater than 1, the function graph should be increasing function, and then looks like this. This y-intercept is what? That is A. And then the graph is keep increasing because the base is bigger than 1. What about y equals 2 times 3 to the x powers? Y-intercept is what? 2. Base is 3 is greater than 1. So that must be increasing function graph. What if b is greater than 1 and less than 1, greater than 0 and less than 1, between 0 and 1? So the y equals a times b to the x powers, the same y-intercept, right? So a is y-intercept. But if b is between 0 and 1, like 1/2, 1/3, 0.5, that is a decreasing function. So graph looks like this. Path is to that a, and then closer to the x-axis. For both graph, x-axis is asymptote. Can we summarize something? For both graph, number one, they have the same domain. Domain of both function is negative infinity to positive infinity. Number two, they have same range. Range is x interval that function exists, right? So the function graph is always above the x-axis. There is no any function below the x-axis. So the function value supposed to be always positive. So y is always greater than 0 to positive infinity. So both graph has same domain, same range. Okay, for both graph, they have same y-intercept. That is a, if that a same numbers. What is the difference? But they have different function, right? If b is bigger than 1, that's increasing function. What about b is between 0 and 1. That function will be decreasing. So only one different thing. One of them is increasing. The other one is decreasing. In the modeling problem, that a y-intercept is what? Initial value. In the modeling problem, if base is bigger than 1, okay, that function graph is increasing. So we call this kind of model as a growth model. What if the base is greater than 0 less than 1? In the modeling problem, okay, the function graph is decreasing. So we call that modeling problem decay model. The first problem is this. 3x minus y equals 12. What is the value of x to the x powers over 2 to the y powers? Find this value, okay? So what is y equals? So that is y equals form. Y is 3x minus 12. Okay? Solve this given equation for y. Y equals 3x minus 12. Now, I will replace this y with 3x minus 12. In other words, I'm going to substitute 3x minus 12 for y. There will be 8 to the x powers over 2 to the y powers. But y is what? 3x minus 12. From now, we have to use some exponential rules. For the numerator, we have to use power of power because 8 is 2 to the third power, right? Then whole thing is x power over 2 to the 3x minus 12. That is 2 to the 3x power divided by 2 to the 12 powers. 3 powers and x powers, right? 2 to the third power to the x power is power of power. So we multiply those two exponents, 2 to the 3x power over 2 to the 3x power is not changing, and divide by 2 to the 12th, change to multiplication, times 1 over 2 to the 12th. Cancel out these two. And then what is left? Just 1 over 2 to the 12 power is left. 1 times reciprocal 2 to the 12th over 1, which is 2 to the 12th. So A is the answer. Number 37, Jessica opens a bank account that earns 2% interest compounded annually. 2% interest compounded annually. Okay, that means that interest is actually coming in your account one time a year. Okay, one time a year. If the interest system is compounded quarterly, that means 4 times a year. What about compounded monthly? That means 12 times per year, right? But in this problem, just compounded annually, okay? So actually, so many banking problem, if you understand this formula, it's very helpful. Amount in your account is equal to principal money, P, times 1 plus R, annual rate of your interest, over N. That N is actually how many times actually interest coming in your account. I told you monthly means 12, quarterly means 4, annually means N is 1. And then T, and then T means what? Number of years. So to find actual amount of money in your account, if you use this, okay, you can find it. P, principal money for initial invest money, times 1 plus annual rate over N to the NT powers. In this problem, they gave you actually formula, right? Amount of your money is 100 times x to the t powers. So P is what? 100. Then what is x? 1 plus R plus N. In this case, N is 1 because it's annually. So it is exactly exponential model problem. It's 8 times b to the x powers form. And that A is what? Initial value y-intercept, initial invest money, initial deposit money, which is $100. What is the value of x is in the expression? So principal money is 100, right? Times 1 plus, what is the annual interest? 2%. 2% means 0.02, right? Over 1 to the t powers. So x is actually this part. This part is x, which is 1.02. So x is what? 1.02. Which of the following is equal to a to the 2/3? A to the 2/3 is equal to cube root a squared, right? Cube root a squared. So D is the answer. D. In planning maintenance for city infrastructure, a civil engineer estimated that starting from the present, the population of a city will decrease by 10% every 20 years. So you have to understand 10% every 20 years. 10% every is increase? No, will decrease. If the present population of city is 50,000, and then say 10 years from now, what is the equation? All right, number one, 10% decreased, right? That means still 90% is left. So in exponential model, initial value 50,000 times, to find the 20 years later's population, you have to multiply by 0.9, 10% decreased. That means still 90% is left. So 0.9. How many years? After 20 years, okay? What about after 40 years? That means 0. Times 9, 0.9 to the second power, right? Because this decreased 10% twice for 20 years and 20 years, right? So that exponent supposed to be t over 20, right? If t is 20, you're going to multiply it by 0.9 one time. What about 4 years later? If t is 40, 0.9 squared, right? Because that 2 times decreased 10%. So this is the answer. D is the answer. D. Number 16. A to the b over 4 power to 16. And then what is the possible value of b? A to the b over 4th into 16. You find the possible value of b, and then a and b both are positive integers. Okay, I want to change 16. Okay, 16 to the exponential expression like 2 to the 4th power or 4 to the 2nd power, something like that. If it is 2 to the 4th power, is equal to a to the b over 4. If a is 2, b is 16, they're going to be 2 to the 16 over 4. That is exactly 2 to the 4th powers. So what is A, what is b? A is 2, b is 16 is one possible answer. What about that is 4 to the 2nd power? That means 4 to the 8 over 4. In that case, what is A, what is B? A is 4, and then B is 8. So there are two possible answers. That's why it asks you one possible value of B. Your answer is supposed to be 8 or 16. Which of the following is equivalent to 9 to the 3 over 4 powers? I want to change this 3 squared to the 3 over 4 powers, because 9 is 3 squared. And then it is a power of power, so I'm going to multiply it by these two powers. 2 times 3 over 4, which is 6 over 4, so 3 over 2, which is m over n powers form. So the denominator is 2 radical, that means square root, right? That's the square root 3 to the 3rd. And then this is 3 squared times 3. Squared number can go outside. 3 can go outside, but this 3 is not squared number, still inside. So 3 root 3 is the answer. What was the formula? I can quickly give it a to the mth root a to the mth powers. That is equal to a to the m over n. 3 over 2 is m over n. That's why 2 is here, 3 is here. Number 11. expression this, where x is bigger than 1 and y is bigger than 1, is equivalent to which of the following? So if you see these choices A, B, C, and D, all this expression is radical expression, right? So we can change radicals to this. How? At first, x is negative second power in the top, and then y is have negative power in the bottom. Okay, if you switch the position from bottom to top or top to bottom in the fraction form, negative power will change to positive power. So this x or negative second power, if you come to the bottom, there'll be x to positive second power, then y to negative power. If you go to the top, numerator, y to the first power. Change it like that. So y to the first power times y to 1/2 power over x to the second power times x to the 1/3 power. It is product of power. Just add to exponent. Don't multiply. You have to add it. So 3 over 2. 1 plus 1/2, 3 over 2. What about denominator? X to the 2 plus 1/3. So 7 over 3. That is equal to square root y cubed over cube root x to the 7th power. The numerator first is y squared times y root y. And what about bottom? It's cube root, right? So cubed number inside the radical can go outside, not squared. So what about x squared cube? That's 6 powers, right? But it is a 7 power. So we need one more power times x. This part actually going to be x to the 7th power. 2 times 3 is 6. 6 plus 1 is 7. And now, any cubed number inside this cube root can go outside. So, x squared can go outside. This cube and cube to cancel out. But that x is still left inside in cube root. That's why this answer. Number 27. The world's population has grown at the average rate of 1.9% per year since 1945. There were approximately 4 billion people in the world in 1975. Which of the following functions represent the world's population P in billions of people T years since 1975? So we have to find the population since 1975. So the population at 1975, the initial value, it is given 4 billion people. So the function is a times b to the x powers, right? But initial value is what? A. A is 4 in this case. The population of t equals 4 times. And then what percent increase? 1.9% increased. So next year, it will be 119% of the previous year's population. So you have to multiply it by 1 plus 0.019. Like interest rates, okay, it's a rate of the increasing rate of population. It's like interest rate in banking problem, 1 plus R. But R in this case, 1.9%. And then after T every year, so T powers, right? So it is 4 times 1.019 to the T powers. A is the answer. So one more time, into the y equals a times b to the x powers. This is exponential function. A is y-intercept and initial value. In this case, 4 billion people. That's the initial value. How much increasing? Every year, 1.9% increased, right? So 1 plus 0.019. So from 100% increased by 1.9%. That's why you have to multiply that with 119%. So 101.9%. So 1.019 post B base B. So final function form is what? 4 times 1.019 to the t powers. We just quickly run exponential rules and the functions. You remember these tenors, please, okay? These tenors, okay? Including radical equation, radical expression to exponential expression, or sometimes you have to use what? From exponential to radical. And then the model problem or function problem, a is y-intercept, and then a is at the same time initial value. And then b is the base is bigger than 1, increasing, gross model. As b is greater than 1, greater than 0 and less than between 0 and 1, that means that decreasing function graph. Okay, still a is initial, but it's a decay model. Okay, so remember every these things and then we're done. Thank you so much for watching my video, and then please subscribe and like and then turn on the notification. I will post at least 1 video every week, sometimes 2 videos, sometimes 3 videos a week. Thank you so much. Bye bye.